Okay, going to continue with a few more examples here. This function now is a function involving logarithmic functions. So remember, in these problems we are going to be finding the intervals where the function's increasing, where it's decreasing, and the location of any local extrema. Now, one thing you want to be careful about in the problems are always think about the domain. What is the domain for this function? What's the domain? I mean, x can be anything, right? What about natural log of x? Do you remember something about the domain of the natural log function? I hope so. Right? The domain of the natural log function is what? Only positive values. You can only plug in positive values. And the reason that was, remember, the domain of the log function is the same as the range of the natural exponential function. And the range of any exponential function is positive values, right? Greater than 0. So you do need to remember the domains and ranges of these basic functions. That's important because later on I've seen people answer this question and include negative numbers in intervals where this function is increasing or decreasing, and that can't be because that's not even in the domain of the function. Okay, derivative time. How am I going to find the derivative of this function? What rule am I going to have to use here? I hope you're saying product rule. If you did, pat yourself on the back. That's very good, right? So I take the derivative of the first function times the second plus the first one times the derivative of the second, right? Derivative of x with respect to itself is 1. Derivative of the natural log of x is 1 over x. And we get what? 1 times natural log of x. X times 1 over x is 1. So very simple derivative. So the question is, when is this derivative equal to 0? Well, it's going to be equal to 0 when the natural log of x plus 1 equals 0. Which is true when the natural log of x is equal to negative 1. Do you remember how to solve logarithmic equations? Well, in this case, we can just rewrite this logarithmic equation in its exponential form. Remember, what is a logarithm? It's an exponent. It's a power. It's an exponent. It's the power on the base, right? So negative 1 is the power on the base here. What's the base in this case? Natural log. It's the base e needed to get x. So the base e raised to the logarithm, which is negative 1, must be equal to x. Right. So this tells me that x equal what? E to the negative 1 is 1 over e. That's the critical point. Okay. So again, you might need to review how to solve logarithmic equations. Very important. You'll encounter them from time to time. All right. Do my sign check now. And this is where the domain comes important, right? The domain was everything greater than 0 up there. So when I do my sign check, I'm going to say everything greater than 0. So I'm going to emphasize that, everything greater than 0. My one critical point is just 1 over e. E is about 2.7 something, so this is a number that is slightly larger than 1/3. And the derivative there is 0. What about values less than 0? Okay. Well, in order to think about that, you need to know the behavior of the natural log function, because the derivative is the natural log of x plus 1, right? So let's take a look at the natural log function here first of all. So we should know that the natural log of 1 is 0, and as we take the natural log of x and x gets closer and closer to 0, we start to drop off. We're approaching a vertical asymptote here. X equals 0. The y-axis is a vertical asymptote. Going in this direction, we continue to increase. So this is a rough sketch of y equal to the natural log of x. So you need to remember that. Okay. So What about 1 over e? 1 over e, as I said, is slightly more than 1/3. Whatever it is, 1 over e. Say this is 1 over e right here. Then what's that value going to be? What's the natural log of 1 over e? What's the natural log of 1 over e? Well, I mean, it's right here in this connection here that we talked about, right? The natural log is the power. What's the power on the base needed to get 1 over e? E to what power is 1 over e? Answer, e to the -1 power, right? So this is down here, -1. Right? And that's important, right? That's exactly what we said, right? Is if I plug in 1 over e here, I'm going to get natural log of 1 over e is -1. -1 plus 1 is 0. That's what we said. The derivative is 0 at 1 over e. But notice, for values less than 1 over e, between 0 and 1 over e, what's the value of the natural log? It's going to be less than -1, right? Like -2 or -3 or something, right? It's less than -1. So when I come over here, I'm going to get a number less than -1 plus 1. The derivative will be negative. If I plug in something greater than 1 over e, the natural logarithm is greater than -1, like -1/2 or something. And if I plug in that value, I'll have it, adding 1 to it will make it positive. Or if you just want to say at 1, when 1 is over here, I can plug in 1. Natural log of 1 is 0. 0 plus 1 is positive 1. Important thing is positive on that interval. Okay. So we can now answer our questions real quick now that we have the sign checked. P of x is increasing on the interval from what? Where the derivative is positive, 1 over e to infinity. P of x is decreasing on the interval from what? 0 to 1 over e. And this is where it's important, right? I see that some people say from -infinity to 1 over e. Well, no. Remember our domain of our original function. You can't plug in non-positive numbers. Only numbers greater than 0. Do we have a local maximum? Remember, local maximum means the sign of the derivative changes from positive to negative. Do we ever change from positive to negative anywhere? No. We only change from negative to positive. So we have what? A local minimum at x equal 1 over e. There is no local max. I'll just say max for short here instead of maximum now. We have a local minimum at x equal 1 over e. Okay, let's try another example. Look at a rational function. It's going to be dividing by something, so involving the variable, so it's important to talk about domain, right? But what is the domain? The domain here. Will I ever be dividing by 0? T squared plus 1 is what I'm dividing by? No. The denominator will be always what? Since t squared is always a non-negative number, the denominator is always 1 or more. So the domain is all real numbers. Okay. So how am I going to find the derivative of this function? What rule is going to come into play here? What rule are we going to use? Well, you said quotient rule, give yourself a cookie. And a glass of milk to go along with it. Alright, quotient rule is what I'm going to use here. Now you could rewrite as a product and use product rule with the chain rule as well. So remember how that works, the derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. Derivative of t with respect to t is 1. Derivative of t squared plus 1 is 2t. And what do we have up top here? We've got t squared plus 1, right? 1 times that. Now be careful, minus t times 2t is minus 2t squared. And t squared, I get 1 minus what? T squared minus 2t squared is minus t squared. Negative 1t squared, so I'll just rewrite it that way. There's my derivative. Now, when is this derivative going to be equal to 0? Well, r prime of t is going to be 0 when what? The numerator is 0. This is easy to solve, right? I can factor this, difference of squares. And so t is equal to what? Plus or minus 1. Those are my critical points. Or critical values. Okay. Do our sign check. The domain was all real numbers again. Critical points were negative 1 and 1, where the derivative was 0. Plug in a number less than negative 1, like negative 2, into my derivative. 1 minus negative 2 squared is 4. 1 minus 4 is negative. Notice I'm squaring this stuff, right? T squared plus 1. Anytime I square a quantity, it's always positive. So negative divided by positive is negative. Between negative 1 and 1, I'll plug in 0. The bottom is positive. 1 minus 0 is positive 1. Positive divided by positive is positive. Plug in something bigger than 1, like 2. 1 minus 4, negative divided by positive, negative. Again, you can just use your calculator, right? Plug in values into the derivative to do the sign check. Okay. So now we're ready to answer our question, right? So this is the easy part, right? R is increasing on the interval where the derivative is positive. R is decreasing on the interval where the derivative is negative. Do we have a local maximum at all? Yeah. Derivative changes from positive to negative at t equal 1. And what about a local minimum? Going from negative to positive in the derivative, decreasing to increasing at a local min at negative 1. So our Dudomworks has a local minimum at t equal negative 1. Notice our answers are consistent with what we said here, right? If we have a local max at positive 1, we must be changing from increasing to decreasing. Indeed, that's what's happening. We're saying we're increasing up to from negative 1 to 1, and then from 1 to infinity we're decreasing. So right at 1 we're changing from increasing to decreasing. We got a local max. So make sure your answers are consistent here, you know, as a check, you know, to make sure that you're getting those, not making a mistake there. It's a good idea to check and see if your answer is reasonable. All right, last example. This one involves an exponential function. So we've done a logarithmic function, a rational function, a trigonometric example in the previous video, and now we'll do an exponential function. What's the domain for our function here? E to the negative x domain is all real numbers. We can raise e to any power, negative, positive, 0, anything. So I take the derivative. Derivative of x is 1. Now e to the negative x, what rule do I have to use there? Chain rule, right? So e to the u is the outer function, inner function is negative x. So I get what? Plus e to the negative x, right? Derivative of e to the u is e to the u times what? Times negative 1, derivative of the inner function. So this is by the chain rule. And so I get 1 minus e to the negative x, or 1 minus 1 over e to the x. So when is h prime of x equal to 0? When is this thing going to be equal to 0? Well, 1 minus what is 0? 1 minus 1. So it's going to be 0 when 1 divided by e to the x is 1, right? Or when e to the x is equal to what? 1. If e to the x is equal to 1, what do I have here? 1 minus 1, I get 0. And when is e to the x equal to 1? Well, if I take the natural log of both sides, I could also write it, basically writing it in logarithmic form. Natural log of 1 is what? 0. What's the natural log of e to the x? Just x. One critical point at x equals 0. So now we do our sign check. Real easy sign check. The domain was all real numbers. At x equals 0, the sign of h prime is 0. And if I plug in a negative number, what's going to happen? Well, you want to think about the graph of y equal e to the x here as we're answering this question. All right, here's the graph. You need to know what it looks like, right? So this is x and this is y. 1. The graph of y equal e to the x looks like that. All right. At 0 it's 1, e to the 0 is 1, and then we're greater than 1 for values of x greater than 0. For values of x less than 0, we're less than 1, right? Getting closer and closer to 0. We never touch the x-axis. There's a horizontal asymptote here. So for values that are negative, e to the x, for any value of x that's negative, e to the x is going to be what? Less than 1. Less than 1. Right? So think about my derivative then in that case. If this number is less than 1, like say a half, just say a half, right? 1 divided by a half is 2, right? 1 divided by a half is 2. 1 minus 2 is a negative number. And so our sign is going to be negative for values less than 0. For values greater than 0, the value of e to the x is going to be greater than 1. Right? And so I have 1 divided by a number greater than 1. That's a number that's smaller than 1. 1 minus a number smaller than 1 is going to be a positive value. Again, you can just plug in a negative number into this derivative here. Is it positive or is it negative? Right, to get these signs. All right, we're ready to answer our question. It's real easy. H is increasing on the interval where the derivative is positive, so that's everything greater than 0. H is decreasing for values less than 0, where the derivative is negative. Do we have a local maximum? Do we change from derivative positive to derivative negative? No. There's no local max. But h does have a local min, doesn't it? And that occurs at x equals 0, right? Derivative changes from negative to positive at that point. Well, there's lots of different types of functions and combinations of functions we can create. And so in the homework you'll need to work plenty of examples. So I've done several examples, but that doesn't by no means exhaust all the possible functions you can encounter. And you'll also note that you'll need to be able to solve polynomial, rational, exponential, logarithmic, and trigonometric equations. So you'll need to review those ideas. Most of them aren't too terrible. I mean, this is not a difficult problem here, but some of them can be a little tricky. And so please get into that homework and then ask questions during my Zoom hours.